Hello everyone, welcome back to the linear algebra series. So in the last lecture, we looked about two different examples. So regarding why do we need linear algebra? So one was regarding, one example was to solve the linear equation and another was to find the optimal parameter value. So we'll continue with the second example and try to understand what exactly vectors are. So let us consider we have the histogram as we saw in the last lecture, and we try to draw a normal distribution graph over that. And if we draw the normal distribution graph, we can see that this graph can be defined based on two different parameters. That is the mu, which defines the height of the graph, and the sigma value, which defines the width. So we know that normal distribution curve we can define using this particular function. You don't need to worry about this function. For now, we will try to understand with this example what exactly parameters are and where exactly vector comes into play. Okay, so we have the following curve. So and we can define the curve using the parameters such as mu and sigma. Now, once we know that we have two parameters, what will be the optimal value for these parameters? So, in order to find the optimal parameters, first we'll take any particular value of mu and sigma and just compare whether it is good fit for the histogram. So we'll keep on changing the value of mu and sigma until when we find the optimal value. So, uh, so in this case, since we have two parameters, we can understand like this is something regarding two-dimensional scenario, and it is a space of mu and sigma. So vectors are actually mathematical objects that have magnitude and direction, and vectors move around some spaces, parameter space. Uh, so in order to find the optimal value, we first will take one particular point. We will then check whether the curve exactly matches the histogram or not. When we'll keep on iteratively change the value of mu and sigma until we find the good fit. So this mu and sigma, these are the little move around the space. They need not be to move around a physical space, but they are actually the move around the parameter space. So in the parameter space of mu and sigma, we can associate this particular dot with a vector considering its magnitude and direction from its origin. So if we draw a line associated with this R, so we know the magnitude. So for example, if this is 0 and here it is 1, so we know that magnitude for this is 1, and the direction, since considering if this is a positive direction of mu and sigma parameter space, then we know its sign and the magnitude. If we understand vectors, basically linear algebra, and understand how to get to the correct value of the in a steepest way, that is the fastest way. So we can understand this how to reach to the correct value in the steepest or fastest way. We can understand with the study of calculus. So once we know what the vectors and calculus, we can solve this such kind of problems. So vectors don't need to be a geometric object in a physical space. They can describe a direction along any sort of axis. So here we saw the vectors in the 2D space of mu and sigma. Another example, let us consider we have space of cars. So space of cars, you can define a car based on the RPM speed, what fuel it is. So we can describe this as a list. So this is the structure of a vector in the space of all cars. So with this particular structure, we can define, okay, this particular structure defines this particular car. So at the end, we know vectors are some mathematical object that has magnitude and direction. Okay.